Welcome to our presentation. So what is a histogram? We know that it looks like this, but what does it actually do, and how is a histogram different from a bar chart?
To start, both of them can analyze univariate data. This means in my entire dataset, I'm only analyzing one variable or one column. A histogram is a graphical representation that displays the distribution of continuous data. If you don't know what continuous data means, the term continuous refers to the absence of distinct categories or intervals. Instead, the data can take on any value within a continuous range. Examples of continuous data include measurements such as height, weight, temperature, time, and distance. An easy way to figure out whether something is continuous is by asking yourself, can this be represented on a number line? A classic mistake would be to think that something counted is continuous. It is not, because you can't count 1.35 apples. The x-axis represents the range of values of the continuous variable being analyzed. It is divided into equal bins. For example, I can have bins of $100 intervals like in this example, or $5 intervals. The y-axis represents the frequency or count of data points falling into each bin. It shows how many data points are within each interval. Sometimes in density histograms, we would also use the percentage of a bin within the sample, but that's something to worry about later. In a histogram, the bars are typically adjacent to each other with no gaps between them. This indicates that the data is continuous and falls within specific intervals.
A bar chart is a graphical representation that displays categorical or discrete data. This is essentially anything that's not continuous. The x-axis represents different categories or groups under analysis. The y-axis represents the values or frequencies associated with each category. In a bar chart, the bars are separate from each other with gaps between them. This indicates that the categories represented on the x-axis are distinct and not part of the continuous range. So how is a histogram useful? Suppose we have a data set containing the max scores of students. We need to find the center of the distribution so we can reward students above average for their academic success. Let's see how the distribution can influence what we label as the average performance of this test. For example, let's say there were some exceptionally difficult questions on this test that most students struggled with, resulting in most students earning very low grades. This skews the distribution to the right, with a long tail of higher grades and a peak of grades towards the lower end. The right skewed distribution, also known as positive skewness, occurs when the tail of the distribution extends towards higher values, while the majority of the data is concentrated towards lower values. In this case, the high grades of a few students would result in a long tail towards the right side of the distribution.
When calculating the mean grade without considering the skewness, the presence of the high-achieving students would inflate the average, making it higher than what most students actually earned. This means that fewer students would be rewarded. To address this issue, using alternative measures of central tendency, such as median or trimmed mean, would be more appropriate. The median represents the middle value when the grades are arranged in ascending or descending order, and it is less influenced by extreme values. Similarly, the trimmed mean, which excludes a certain percentage of extreme values, can provide a more robust measure of the typical performance. By utilizing measures, hence, like median or trimmed mean, we can obtain a more accurate representation of the typical student performance, considering the right skew distribution caused by the high-achieving students. Thanks to the histogram, we get to visualize the distribution of our data before we decide on the center.
So we're going to do a demonstration on the GDC on how to plot a histogram. We're going to first come to Stat here. We're going to press Edit, and here we can enter our data set of this whatever we want to analyze and make a histogram on. So we can just enter random numbers. Okay, and then after we're done with that, we can come to second y equals, so then we can get to stat plot, and then make sure our first plot here is set to be a histogram. So we can change the type here. It can be a scatter plot, it can be a line graph, but we're going to do a histogram here. And make sure that the X list is L1, which is the data set that we set up. And then after we're done with that, we're going to do zoom. And we're going to come here to 9. So we're going to press 9. And great, we have our histogram.